In this lesson, we will learn how to graph straight lines using intercepts. And before we get into that, we're going to go ahead and take a look at the graph that's on the screen and also on your note page. And my question is, where does the line cross the x-axis? So the first thing we need to remind ourselves of is which of these black lines is the x-axis. The x-axis is the horizontal axis. So my question, where does this line cross the x-axis? Well, it crosses at this point right here. And my second question then is, where does this line cross the y-axis? Well, the y-axis is the vertical axis, or the up and down. And that's true on every graph. Remember that this coordinate plane has another name. It's also called the Cartesian plane, which you guys have been learning in Mr. Mill's class about René Descartes, and that's who this is named after, Descartes, and it was called the Cartesian plane. So where does this line cross the y-axis? Well, it crosses right here at this point. So those two dots that I've just put on the graph are our x and y intercepts, and we can name these points using ordered pairs, which is x, comma, y. Let's start with this one. I've gone to the right 1, 2, 3 times, and I've moved up and down none. And on this point up here, I have moved 0 from the origin, but I have moved up 1, 2, 3, 4, 5. Let's go ahead and try this again. Where does this line cross the x-axis? Well, it's going to cross the x-axis here. And where does this line cross the y-axis? Here. Let's go ahead and name those 2 points again. I'm going to name them, giving them an ordered pair, x comma y and x comma y. I went from the origin left 1, 2, 3, 4, 5, so that's at -5. And I have not moved up or down, so that's a 0, -5, comma 0. And on this point, I've not moved left or right, so that's 0, but I have moved up 1, 2, 3 times. Remember that the best part about these videos is that you can pause them, go back and rewind or rewatch something if it's going too fast, or if you just needed to see something for a second time. So on this next page, we'll see the actual definitions for what is an x-intercept and what is a y-intercept. We just did this on 2 graphs, but here are the definitions in words. The x-intercept is the x-coordinate of a point where the graph crosses the x-axis. And so if we go back and look at these again, the x-intercept is the one that crosses the x-axis. Look at this, -5, comma 0. And let's go back to the first graph, 3, comma 0. What do those 2 points have in common? The x-intercept has some value here, but the second number is 0 because it is where y equals 0. The y-intercept is the opposite of that. The y-intercept is the y-coordinate of a point where the graph crosses the y-axis. Let's jump back and look at these again, looking at the y-axis. Here's this point, 0, comma 3. And on my first graph, 0, comma 5. What do you notice that they both have? They both have a 0 first, and then they were followed by some number that was on the y-axis. So our intercepts have x followed by 0 and 0 followed by y. That's what the intercepts will look like. So now we're going to be asked to find the intercepts without a graph. With the graph, it was easy. We could kind of just look at the graph and write down the points, but now we're being asked to find it. And this is how we will do this. We're going to find the x-intercept by plugging in 0 for, well, what was our x-intercept? Our x-intercept was some number x followed by 0. So to find the x-intercept, I need to plug in 0 for y. So let's go ahead and do that first. I've got my equation, 3x plus 4y equals 12. And I'm going to rewrite it, 3x plus 4. Now instead of writing y, I'm plugging in 0. So I'm going to use my empty parentheses. And then in those empty parentheses, I'm going to plug in the number 0. What is anything times 0? It's 0. So this really has just kind of gone away. I could write 3x plus 0, but I'm too lazy to do that. You guys know that. So instead, I'm just going to write 3x equals 12. How would I finish this problem? I would divide both sides by 3. And I'll find, once this becomes a big coefficient of 1, that 1x, or just x, equals, what is 12 divided by 3? It is 4. So here is my x-intercept. My x-intercept is 4, 0. So how do you think we're going to solve for the y-intercept? For the y-intercept, we're going to do the opposite of what we did over here. We're going to plug in 0 for x. Because if I flip back to that page before this, where I have my x, y, the y-intercept has a number here, but it has a 0 in front. So I'm going to take that same equation, 3x plus 4y equals 12, except I'm going to plug in 0 for x. So here's what that will look like. 3, and I'm not going to write x, I'm going to plug in a 0 here, plus 4y equals 12. I'm going to plug in 0 right here where the x used to be. This is supposed to be an x, but I'm going to plug in a 0. And what is 3 times 0? 0. I could write 0 plus 4y, but I won't. I'm pretty lazy. 4y equals 12. And to solve this equation, I need to divide both sides by 4. That's going to give me a big coefficient here of 1y. Instead of writing 1y, I'll just write y. And 12 divided by 4 is 3. So I just figured out that y equals 3. And that makes sense. I have an empty space here where I can write that in this case y equals 3. So what I've just found is my x-intercept and my y-intercept, and I would be able to graph those 2 points, and that's all I need to graph a straight line is 2 points. Here's another one that I would like for you to try on your own. You're going to set up this same process. You're going to plug in 0 for y to find your x-intercept. There will be some number here where the x belongs. And you're going to find the y-intercept by plugging in 0 for x. And you're going to get down to the bottom, and there's going to be a 0 here where the x belongs, but there will be some number here for the y. And what we're really going to use this for is to learn how to graph. So the x-intercept, I plug in 0 for y, and I'll go ahead and put that 0 down there. To find the y-intercept, I plug in 0 for x, and that 0 is going to go right there. I'm going to use that same process that I did before, but this time I'm going to take those two intercepts over here to the graph and I'll be able to graph a straight line. So let's go ahead and try this. I'm going to do x minus 2 equals 4, and instead of writing y, I'm plugging in a 0. And 4 times 0 is 0. So I've got x minus 2 equals 0. Well, how do I get this x by itself? If I had my balance line here, I would need to add 2. What I do on one side, I must do to the other. And this goes away. Remember, that becomes a 0 pair. So what I have now is x equals 2. X equals 2. That's the point. 2, comma 0. Let me go over here to my graph. Let me grab a bigger pen, and I'll go to x equals 2. That's my x-intercept that I just figured out. Let's try that with a different color over here for a y-intercept. This time I'm plugging in 0 for x. So I'm not going to write x minus 2. I'm going to write blank minus 2. And a 0, that's what I'm filling in there. That's where the x was, but now I'm using 0. And that equals 4y. Well, 0 take away 2 is negative 2. Negative 2 equals 4y. And to finish this problem, I need to divide both sides by 4. So I will get y equals negative 2 over 4 can be simplified to 1 over 2. Y equals negative 1/2. That's what will get filled in right here. And I'll go over to my graph to put this point on my line. And I go left, right, 0, and I go down 1/2. That would be in the middle of the 0 and the 1. And then I can take a straight line and draw a straight line through those points. I'm going to extend that line in the opposite direction. Oops, that's not so straight. Let's extend that line all the way, keep going through that 1/2, negative 1/2. And I will finish it by putting arrowheads on both sides, showing that the graph goes on forever in both directions. On your note page, you have a place to try one of those on your own. So for the you try, you're going to be doing the same thing, finding the x and y intercepts for this equation, 2x plus 5y equals negative 10.